right, welcome to CCU today, everyone. I'm your host, Brett Cease, and tonight's discussion is on climate and weather. We're lucky enough to have our own Rick Knight, along with television meteorologist Bob Lindmeier and Dr. Jennifer Francis with us, and let's jump in. So tonight's learning goals: after tonight's lesson, attendees should be able to distinguish the difference between climate and weather events, understand how climate change is impacting the Arctic region and jet stream, provide specific examples of how climate change is predicted to impact your own local weather patterns, and demonstrate successful practices in communicating how climate change connects to observed weather. The agenda tonight is pretty straightforward. We're going to have a quick review about extreme weather events, Arctic amplification and anomalies, and the jet stream impacts as well, all by Dr. Francis. And then Bob Lindmeier is going to cover media coverage of global warming, climate central predictions, and connecting it back to how you can find that out from your own area. And then lastly, we'll have more of a discussion and Q&A. So
Rick Knight is a chemist and a chemical engineer who has enjoyed a 40-year career in energy research. Rick received his BS in chemistry from the University of Illinois in Chicago and then studied chemical engineering at the university's the Illinois Institute of Technology before launching a career in cutting-edge R&D on low-emission burners, pollution control, gasification, fuel cells, energy efficiency, solar heating, and advanced biofuels. I'd call that a diverse portfolio. He has published dozens of papers, holds 10 patents, all right, we might get to hear about that a little bit, and has managed projects up to $20 million for state, federal, and industrial clients. And Rick is now retired, but stays very active as Illinois state coordinator and Chicago Southwest chapter leader. Thank you for being on the call tonight and for moderating, Rick.
Well, thank you, Brett. As Brett said, we're really honored to have two wonderful guests. One is a renowned climate scientist, Jennifer Francis, and the other is a renowned TV weather meteorologist up in Madison, Wisconsin. I'm going to start with Dr. Francis because she has recorded her presentation. She unfortunately couldn't be with us live tonight. And then when her presentation is done, I'll go ahead and introduce Bob Lindmeier. So Dr. Jennifer Francis is a research professor in the Department of Marine and Coastal Sciences at Rutgers University in New Jersey. She earned a BS in meteorology from San Jose State in 1988 and a PhD in atmospheric sciences from the University of Washington in 1994. At Rutgers, Dr. Francis taught courses in satellite remote sensing and climate change, and is internationally known for her research on the linkages between the Arctic and global climate. She and her husband are also world-class sailors who once circumnavigated the world in a sailboat, including Cape Horn and the Arctic. So something that not too many of us can claim. Anyway, that's the background of Dr. Jennifer Francis, and I was so happy to have her at the national conference too in DC, and you're going to see her wonderful presentation right now.
And today I'm going to give you a very brief sort of summary and a little bit of an update on some of the research that's been going on to try to understand how the rapidly warming and melting Arctic is affecting weather patterns down here where we all live in the mid-latitudes, and in particular, some of the connections that we think are leading to increases in certain types of extreme weather. So let's get started. So just looking back over the last few years, we've seen an increase in certain types of extreme weather. For example, the UK, the last few winters, has seen just horrific storms battering their west coast. We've seen places like northern Japan, where they're used to getting a lot of snow, but in the last couple winters, they've seen some unbelievable amounts of snow. And you can't even picture the snowplow that keeps this road clear. I'd love to see it someday. Just last summer, we saw unprecedented flooding in Louisiana from rains, heavy rains in that part of the country. And of course, those of us who live in the Northeast won't forget anytime soon the very severe and snowy winter of 2015, where we broke the all-time record for snowfall in Boston, which is saying something because Boston gets a lot of snow. And of course, we've been watching the stories coming out of California for the last few years Up until just this past winter, California's been dealing with a very severe drought, but of course we know that this past winter, some parts of California actually saw record-breaking rainfall and snowfall. So pretty interesting story out there. And we're not the only ones. We scientists are not the only ones keeping an eye on these changing weather patterns. For example, the insurance industry is very concerned about extreme weather in particular, because of course they end up having to pay a lot of money for damage that's incurred by extreme events. So for example, here's some research that's ongoing by a company called Munich Re. They're a reinsurance company, so they insure insurance companies. And what this plot is showing you is going back to 1980, there are 4 different kinds of extreme events. The red ones there are what are called geophysical events, so things like volcanoes and earthquakes and tsunamis. And the other 3 types, the green, the blue, and the orange there, are all related to weather. Now what you notice is that the red bars are not increasing over time, and this is number of events. It doesn't have anything to do with the dollars outlaid because of damage caused by these things. So it's just the number of events. But what you do notice is that the types of events caused by weather are on the rise. So these types of extreme events, those examples that I gave you in the beginning there, all have something in common. And that thing is that they're all caused by weather patterns that seem to be stuck. They're very persistent. And these are the kinds of weather patterns that I'm talking about when I'm discussing how we think the Arctic warming is related to changing weather patterns and extreme events. So let's step back just a little bit and look at how the globe has been behaving over the last few years. And probably you've heard in the news that the last several years we've seen the warmest temperatures on record for a global average. So what I'm showing you here are 2010, 2014, 2015, and those global temperature anomalies or differences from normal in those last 3 years. And these, up until last year, were the warmest years on record. But then when we put 2016 on there, we can see that we've blown those records right out of the water. And in fact, we're butting up against that magic 1.5 degree warming that the Paris Agreement was trying to avoid. So we're getting perilously close to that 1.5 degree warming of the globe. But how does this manifest itself in the Arctic? Well, here we're looking down on the North Pole, and we're looking at an animation of the thickness of the sea ice that floats around on the Arctic Ocean. We're going back starting in the early 1980s, late 1970s, and going up to present time. You can see the scale on the bottom there, showing you that the light blues and purples are when the sea ice is very thin, and as you get up towards the yellows and reds, you have thicker sea ice. So what's very obvious is that as we look at the changes that have happened starting just back in the late 1970s, only 3 decades or so ago, we're seeing a huge change in the thickness of the sea ice. This is not good. In addition to changing thickness, we're also seeing changes in the extent or the real estate covered by that ice cover. So on the top of this figure, you see what the sea ice in the Arctic Ocean looked like back in summer of 1979. And as we fast forward on the bottom part of the slide here to 2012, which was when we had the least amount of sea ice ever recorded, we see that that red and orange is all areas where there used to be sea ice and there is no longer in the summertime. And the reason this is a big deal is because the ocean underneath that ice is very dark. And so when the sun hits the ice, most of that energy is reflected right back out to outer space. It never enters the climate system. It doesn't warm anything. But when we lose all this ice and we make that ocean much darker, much more of that sun's energy is entering the climate system, warming the ocean, melting even more ice, and setting up a vicious cycle that we call a positive feedback. This is not good. So one of the other ways that we look at the Arctic is, of course, in terms of temperatures. And here what I'm showing are the wintertime average temperatures differences from normal over the last 25 years compared to pre-industrial times. So this is showing how the temperatures have changed in the Northern Hemisphere relative to the last several decades. And what you notice is those red colors there right over the Arctic Ocean are telling us that the Arctic has warmed much faster than anywhere else. And interestingly, you see those blue colors over Eastern North America and over most of Asia. And that's saying that it's actually been cooling in those places. So we'll get into that in a little bit. So this change in the Arctic, we think, is a really important aspect of climate change. So if we look now at how the Arctic temperature, which is in blue, going back to the late 1940s, how that temperature has changed relative to the changing temperatures in mid-latitude, so where we all live, what we see is that in the last couple of decades, a very strong warming has been happening in the Arctic. We call this Arctic amplification. Again, thinking back to that map that I just showed you, warming much faster over the Arctic than anywhere else. And you can see that this warming really only started around 1990 or so. So it's a very new signal that we're seeing. And in 2016, this difference in warming was largest ever recorded. And you can see that very clearly. And it's not just largest by a little bit, it's largest by a lot. So why do we care about this Arctic amplification? Well, one of the reasons is how it affects the atmosphere. So if we think about a layer of atmosphere that extends from, say, down here in the United States, all the way up to the Arctic. We know that when the air is warm, it takes up more room. Warm air expands, cold air contracts. So this layer is actually thicker down here in the US than it is up north in the Arctic. So you could think of yourself sitting on top of this layer and looking towards the north, and it would be like you were looking down a hill. Well, the air on this hill wants to flow down that hill just like water wants to flow down the side of a mountain. And this creates a wind. But because the Earth is spinning, that wind gets turned to the right, and it becomes what we call the jet stream. It's a fast-moving river of air high over our heads that encircles the Northern Hemisphere. But let's think back to Arctic amplification now. What's happening with that? We know that the air is warming faster in the Arctic, and so that layer of air is getting thicker faster in the Arctic than it is down here over the United States. So the result of that is to make this hill become less steep. And so there's less force driving that wind and driving the jet stream. And what we expect to see, and in fact can measure, is a weakening of those west to east winds of the jet stream that's created by the flattening of this hill. And when the jet stream gets weaker, it tends to also get wavier. It tends to swing north and south in bigger waves. And we'll talk about why that matters in just a second. So there are two effects of Arctic amplification that we're studying right now. One is the one I just talked about, where we think that the weaker west to east or zonal winds of the jet stream should have an impact on the shape of the jet stream, those waves that it takes north and south. And the other effect is to intensify the ridges. The ridges are those big northward swings in the jet stream. Now let's look at what this looks like on a map. So on the left here is a day in November 2013 when it was very cold in the Arctic, and those red arrows are indicating the path of the jet stream on that particular day. And you can see that it's relatively straight. There aren't a lot of big waves swinging north and south. But if we look at a day where the Arctic was quite warm, in fact, this was the attack of the polar vortex that happened to the eastern US in early January of 2014, you can see those blue areas have migrated away from the Arctic down to lower latitudes. And we see these bigger north and south swings in those red curves that indicate the jet stream. So when we get these big waves like that in the jet stream, they tend to be quite persistent. They tend to stay in the same place for a long time. And in fact, that winter of 2014, we saw a very, very persistent weather pattern in North America with a big ridge over the western part of North America, you can see there. And that contributed to the drought conditions in California. And you can see the big southward dip over the eastern part, which allowed that cold air from the Arctic to plunge south. And that pattern was in place for a very long time. So why do we care about these big waves in the jet stream anyway? Well, it turns out those waves have everything to do with the weather that we experience down here on the surface. So let's look at one of these typical waves in the jet stream, very similar to the one I was just showing you. So the first thing you notice is that north of the jet stream is where the cold air is, and south of it is where it's warm. So the jet stream forms this boundary between the tropical warm air to the south and the cold Arctic air to the north. So whenever the jet stream is south of you, you'd expect to be in that cold air, which was what happened during that January of 2014. But the other thing that happens with respect to these waves is the dynamics of the waves themselves. So in this area where the winds of the jet stream are coming out of the northwest, like over California there, we tend to see very dry and settled conditions. And over on the other side of the country there, where the winds are coming from the southwest, the dynamics are favorable for upward motions in the atmosphere, and this creates a wet and stormy pattern. So if you're in one of these two conditions and that big wave is not changing very much, then think about that very snowy winter in Boston in 2015. We were in that part of the jet stream where it was very wet and stormy, but we also had enough cold air to turn that precipitation to snow. And that pattern was in place for a very long time.
So what about this idea of more intense ridges? Ridges being those big northward swings in the jet stream. Well, we've been working on a new idea that we call it takes two to tango. And let me explain what I mean by that. So if we look back to the good old days, and here we're looking at the Pacific Ocean and North America, and lots of sea ice floating around up in the Arctic. Well, back then, the ice really didn't change much from year to year, so it really didn't have much impact on what was going on in the atmosphere. So if a ridge should happen to come along like this, along with the trough downstream, it really didn't do anything. But if we fast forward to what's going on today, and you can see this big bite of ice taken out of the Pacific side of the Arctic Ocean, as I mentioned earlier, what happens is when we lose all that ice, a lot of extra heat gets absorbed into that open ocean, that dark ocean. And in the fall, when the atmosphere starts to cool off again, all that heat gets released right back to the atmosphere. So let's say one of these ridges came along in the jet stream, and different things cause those ridges to set up in different places. Well, if the ridge happens to be located in this place, it doesn't interact with that extra heat, that warm ocean that's sitting there. So really, the ice loss has no effect. But if something were to set the ridge up right in the same position where all that heat is, then what we'd expect to see is that heat to go into the atmosphere. Remember that bulging of the upper atmosphere because of that extra heat put in, and it makes that ridge bigger and therefore more persistent. Because remember, when the waves get big, they tend to hang around longer. So the weather then associated with that big ridge and the trough, if it's more persistent, is going to make these stuck weather patterns that can lead to various kinds of extreme events like I showed you in the beginning. So what's the situation? How bad is it really? Well, we can look to climate models to help us answer this question. So here we have a set of climate models that were run for different scenarios for the future. So the gray area is running those climate models showing how much sea ice there is in the Arctic Ocean going back to the beginning of the 20th century. So this cloud of gray here is covering all the different simulations by these models and how much sea ice there was in the Arctic Ocean. This black line here is what the real world has been doing, so the actual measurements of the amount of sea ice floating around in the Arctic Ocean. And you can see the models capture the change in the sea ice pretty well. So starting where the pink is are these different scenarios for the future. So the red scenario here is if we do nothing in terms of curbing our greenhouse gas emissions, and we just keep doing things the way we've always been doing. I mean, that is burning a lot of fossil fuels. And if that happens, what the models tell us is that we're probably going to lose all of the summer sea ice in the Arctic Ocean somewhere between 2040 and maybe 2080 or the end of the century. But if we're able to curb our emissions of greenhouse gases, we have the possibility of following this green line and keep some of that ice in the Arctic Ocean. And as I showed you, losing a lot of that ice means that it's darker and we absorb more heat and we exacerbate the warming that's happening in the globe, and we potentially lead to more of these extreme weather events. So it's within our power to do something about this. So just to wrap up here, I wanted to show you what the real jet stream looks like. This is an animation produced by NASA's Science Visualization Studio using real winds in the upper atmosphere. And as we rotate down over North America here, those red and yellow colors are where the winds are blowing very strongly. So you can see pretty clearly where that ribbon of wind that I kept talking about is located. But you can also see what a gnarly, messy, chaotic thing it is. It's not this smooth, simple ribbon of wind flowing around the northern hemisphere. Sometimes those waves are small and sometimes they're big, like right now. And you can see that when they're big, they tend to stay in one place for quite a while, leading to these persistent weather patterns that I'm talking about. So just to wrap up now, I think we're looking at a situation where we know the ice is disappearing in the Arctic rapidly. The Arctic is warming very fast. There's a lot of research going on right now all over the world, different groups and different research institutions, trying to understand the various ways in different seasons and different locations, how the very warm Arctic is going to affect our weather patterns. So stay tuned, because there's going to be a lot more research coming out in just the next few years.
All right, thank you so much, Dr. Francis.
So Mr. Bob Lindmeier is a popular broadcast meteorologist on WKOW-TV, the ABC affiliate in Madison, Wisconsin, where he's worked since receiving his degree in meteorology from the University of Wisconsin in 1979. And he's been chief meteorologist since 1989. Bob holds the television seal of approval from the American Meteorological Society. TV weathercasters, as you may know, are among the most trusted voices on climate change. So it's a great opportunity to hear the inside story on how that is done from one of the best. So welcome, Bob Lindmeier, and take it away, Bob.
The Ellers. The challenge for television meteorologists and media in general is communicating what the climate researchers are publishing. For instance, what Dr. Francis just showed you, it's very important and people need to understand it. But we have a problem. Just in general, you can see the total coverage of climate change in 2015 and 2016 by the networks. And this is minutes, not hours of coverage by the different networks. 2016 obviously was an election year, which brought things down a bit. But you probably also noticed when they were doing their debates, the moderators didn't even bring up climate change as a subject to be debated. So in general, the media has been failing in communicating about climate change over a relatively long period of time. Okay, so media in general has not communicated climate change information effectively. Let's divvy up where can you go for information about global warming? Where does the public trust most centered? Well, number one are climate scientists like Jennifer Francis. 70% of people trust climate scientists. Another well-known one is Katharine Hayhoe, who is someone I try to emulate in terms of how I communicate about climate change. Other scientists are 64%. So when any scientist, doesn't have to be a climate scientist, talks about global warming, there is a trust factor by the public. Third is my profession. Television meteorologists, there's a trust factor. 60% will trust us when we communicate about climate change. Fourth on the list, I do want to stress to all the folks watching this, is friends and family members. Just you talking with your friends, your family about climate change is actually a very effective way to raise awareness about global warming. Okay, so let's talk more about television meteorologists. TV weathercasters' views on climate change look like this. Number one, 95% think climate change is happening. Should be 100%, but 95% I guess we'll take. Unfortunately, only 49% are convinced that climate change has been mostly or entirely due to human activity. This is in line with the general public. You would think that meteorologists that have meteorologist knowledge would be a higher percentage, but unfortunately that's where we're at. And actually this has improved in the last few years. Now of that, 40% are interested in reporting on air about climate change. So it's less than half. Now you might wonder, why is that? Okay, this is just a picture of me on WKOW TV. I'm fortunate to have a management that is supportive of me going on air and talking about climate change. They want me to keep it relative to events that have recently occurred. And I was just on the air a couple of days ago talking about rain events. I'll show you that graphic in just a moment. Unfortunately, what many television meteorologists face is management that do not support them going on air. As you know, it's a controversial subject, politically charged. And TV news in general wants to stay away from controversy. The challenge of getting viewers is difficult. So many people are not watching TV news anymore, so the pie is smaller. So we're battling for a smaller and smaller percentage of an audience. So anything that would disrupt that and perhaps take viewers away is a problem. However, I've been fortunate here in what I've been able to do on air. One of the most important tools that I use for climate change education, not only on TV, but I give many talks to the general public, is using this resource called Climate Central, which researches and reports about the science and impacts of climate change. This is a website that's run by meteorologists, by researchers. It's all peer reviewed. So anything that I pull out of this website to show on air, I'm confident that it is the real science, that it is peer reviewed research, like what you were just seeing from Dr. Francis. Just to give you some examples of some graphics that are put out by Climate Central, and you might have seen this. I've noticed that there are a number of meteorologists that use this. How big is the Arctic iceberg, Larsen C, compared to New York City? So if you took that break off of the Larsen C, made it into a solid ball of ice, you can see how gigantic it is. It's an 8-mile sphere of ice. So when you put it into a graphical representation like this from Climate Central, it's very effective. It's impactful to the viewers. And all I have to do is put my Channel 27 banner on this, and away I go. So it makes it very easy for me to go on air and show the latest on what's going on in climate change, or to use this in my presentation, my PowerPoint presentation that I use. But what I really like to do, especially on air, is relate things locally. Of course, climate change is happening around the world. There's sea level rise. But here in Madison, I can show graphics. And I have just a few examples that I want to run by you. For instance, in Madison, which is in southern Wisconsin, it's the 5th hottest since 1869, the year 2016. As you know, globally, 2016 was the hottest. But Madison was a top 5. Let's show another one. Okay, it's coming in, there it is. Warming winters. The winters have been especially impacted by climate change here in the upper Midwest region. And this is pretty significant when you think since 1970, the warming has been as much as 7.5 degrees. Now this is Fahrenheit. As you know, we go a lot between Celsius and Fahrenheit, but this is a Fahrenheit. And as you know, from 1970 to now, that's a blink in time climatically. So we've seen dramatic warming here in southern Wisconsin, not quite as much as Minneapolis, just been at 7.5, but we've been seeing about 4 degrees of warming just since 1970. Go to the next. Specifically in Wisconsin, we can show graphics like this, which show how the winter season compared to the other seasons has been warming up faster. And basically it's because we're closer to the Arctic here in the northern part of the United States. We're feeling the impacts of the warming that Dr. Francis showed you earlier. So we're especially feeling it in the winter. And again, just another example, and this is, again, specifically for Madison. So this is great because Climate Central has put these graphics and this analysis together for 5 cities in Wisconsin, all the major ones. And they've done this for every city in the United States, this kind of distribution. So more than likely, an on-air meteorologist is going to have specific graphics like this that they can put on air. So again, for Madison, 4.6 degrees warmer since 1970. And again, relating to winter, this I think is pretty dramatic. The average lowest temperature back in 1970, lowest temperature was about 22 degrees below zero. You can see in 2016, it's about 12 degrees below zero. So especially winter at night, we're seeing this huge change. And so obviously our winters aren't nearly as cold since our coldest temperatures are at night. This is a graphic that I showed a couple of days ago on WKOW TV, and it relates to the fact that we have a lot of flooding going on here. We've had 4 or 5 inch rainfall amounts frequently in the last, in the month of June. We're at our 7th wettest June ever. You go to Bismarck, they're in an extremely dry environment right now. And again, that kind of relates to what Dr. Francis was talking about. But again, it shows the trend of 1%, top 1% daily rainfall events. And again, you get the spiking of the annual variations, but the trend is increasing in these extreme rainfall events. And this is one that's really impactful here in the upper Midwest. Yeah, we don't have to be concerned about sea level rise here, but we do have to be concerned about something like this, rainfall events. And then projecting into the future, assuming that we don't change the amount of carbon dioxide we're putting in the atmosphere, if we continue to increase at the rates that we have been increasing, if we just stay status quo, this is a projection, which literally shows that in Madison, over the remainder of the century, we're going to see a change in our climate that's dramatic. In 2000, we averaged 2 days a year of a heat index of 105 degrees or above. By 2030, we're projected to be at 11. And by 2050, which is what, 33 years from now, we're projected to be at 21 days. So we're not talking about the end of the century, we're talking mid-century in terms of how dramatic the climate's going to change in Madison. And this is something that we can communicate to people and it resonates with them. We're not talking about the polar bears. We're not talking about other events happening in the world. We're talking about what's happening right here. And this is, I believe, my last graphic, and I think it's really impactful. And it shows, again, if the computer models, if you take the mid-range of the computer model projections on how much we're going to warm by the end of the century, assuming that we do not reduce the amount of fossil fuels that we're burning, will be 11.5 degrees hotter by 2100. And that would give us, again, the climate of Alexandria, Louisiana. And that one always hits home. I always hear some murmurs, especially when I'm giving these talks in person to people. This is what I think really is important to get across to people, is local impacts of climate. And by using Climate Central, it's an amazing resource. You don't have to be a television meteorologist. Any of you out there that do communication, do climate change communication, can use these resources as well. It's climatecentral.org. So that's my PowerPoint. I believe that's it. There's no others, as I recall. So Rick, I'm ready for some questions.
Okay, great. Thanks, Bob. It's great to see how you use the Climate Central information in that way. So we have some questions on chat. Brett, you want me to go ahead and read those, or do you want to open it up? Yep. I'll go through the ones that we have.
I'll just say, as Rick reads these out loud, we have everyone muted. So after we've gotten a couple of the other questions that Rick's reading from the chat window, feel free to keep using that. But then also you can unmute yourself and click on that microphone icon in the lower left corner, and you should be able to just speak. But we'll go through our chat window first. Go for it, Rick.
Okay, great. There's a mention from Claudia Egelhoff in Minnesota that Paul Douglas is back on local TV. I imagine, Bob, you may know Paul. He was one of the first that I've ever come across TV meteorologists that really came out aggressively on climate change. So rather than a question, that's just something to kind of look out for.
Yeah, he's been one of the leaders, no doubt about it. Paul Douglas has been one of those television meteorologists that early on recognized how important it was to communicate. So he's definitely one of the best known.
So one question that came early on: we have always been careful to relate specific weather events to climate change. Are our capabilities improving such that at some point we might be able to say if specific events are likely due to climate change? Bob, any comments on that?
Very good question. And that's one of the challenges we face. I have to be very careful when we have an extreme weather event to not immediately attribute that to climate change, because you don't know what percentage of climate change is affecting that particular extreme event. What we can.
Would you mind just moving a little closer to the microphone, Bob? I think some of our listeners might have a hard time hearing. Perfect. Thank you.
Is this better? Okay.
Perfect.
Yeah. So what we can say is this is an example of an extreme event that we're seeing increase in frequency. However, one of the big areas in climate change research is in climate change attribution. And for instance, I have this magazine right here. It's from the American Meteorological Society, and it says Explaining Extreme Events of 2015, a Climate Change Perspective. So they have research of specific extreme events that have occurred in 2015, and they've been able to directly attribute that to climate change. So that's something that is increasing. So, and it's very important for us to be able to do that. But there is that time lag. You have to be able to research an extreme event before you can say, you know, to what extent it was due to climate change.
I believe that there's one university where they're really focusing on that. I think it was in New York. Are you familiar with where that work is being done?
I am not.
That attribution work, may have to find that. You know, one thing that when this question is asked of me too, I try to point out to people that there is never a single cause of any extreme weather event. So to say whether or not climate change is responsible is really not a very good question to ask, because it's a factor. And like many other factors, I don't know if I'm stepping over the line of meteorology there, but that's, I think, a good thing to point out.
I think I agree with that statement, Rick.
Yeah. Okay, here's another question. This one is from Dee. Do you find that folks are less concerned about climate change since it's nicer to have warmer winters? She read about this in a Duke environmental report.
That's, you know, there are positives and negatives to climate change. You know, obviously the negatives far outweigh any positives, but still those positives are there. And true, for those that don't like extremely bitter cold winters, the winters are not as cold. But that's where the education comes in, to make sure that they understand all the ramifications, the negative ramifications that are going on. For instance, here in Wisconsin, what I stress is just our snowfall is significantly less. It's been lessening, and that's had a huge impact on recreation during the winter. We're losing millions of dollars. So I'm a golfer, and I like to golf. I can golf earlier in the spring and goes later into the fall. So there are those things. But of course, as we know, those are just a few things compared to all the negatives.
Sure. You might mention to some of those deer hunters up in Wisconsin too, when it's like Alexandria, Louisiana, they might have some problems.
They sure will. And just as I tell this as an example. I went up into northern Wisconsin in February to snowmobile. I hadn't snowmobiled in years. And they had a great snow base. This is in early February. My wife and I get there, planning a week of snowmobiling. It started to rain. It didn't rain for one day, it rained for a solid week. This is in northern Wisconsin. It just doesn't happen. So I personally am experiencing the effects in a negative way.
Yeah. Here's another question. I can't make out the whole name, from Richard something. Have you observed any differences between urban and rural populations or viewers with regard to concern or interest in climate change in your region, Bob?
No, I've given talks both in the city and in smaller towns outside the city, and I really haven't noticed a change. In Madison is a pretty liberal city, so when I talk in Madison, I get a good reception for the most part. When I go outside the city to talk, I'll get a little bit of pushback, but still not much. So I don't really see that dynamic of rural compared to city in their belief in climate change.
One last comment on the chat. More of a comment than a question with regard to the thing about warmer winters and people being happy about that. It's important to point out that we can't cherry pick the positive aspects of climate change. Warmer climates impact mosquito-borne disease, crop yields, energy use, etc. So I just think it's a comment worth noting.
Exactly. It's a long, long list of negatives compared to a very short list of positives.
Well, thank you so much for reading all these questions and for Bob's availability here. We're going to open it up for other participants to provide any input or thoughts or questions they might have. Again, if you're calling in, just press *6. If you're tuning in on Zoom, you can click on that little microphone button. It should be currently with a red slash through it. Click it again and it will unmute you. And we'd love to have other people's thoughts as we continue to have more time for Q&A for another 10 minutes here. You can also use the chat window.
Hi, Bob. This is Wharton Sinkler in Des Plaines, Illinois. And I often want to know, is there a good website or resource for unusual weather events that are happening globally? I know about the wonderground.com blog and also weather.com, but they tend to be very US focused. And sometimes I think it'd be very interesting to see, you know, where are the unusual heat events or cold events or, you know, sort of the type of weather that is interesting to think about in relationship to climate change. You know, is there a place where you can see that that's up to date and well done?
I am not aware of a specific website that highlights extreme events that are taking place across the world at any given time. What I do personally in the evening, as a matter of fact, my bedtime reading is I get on my iPhone and I look up Apple News, and I have it designated to climate change. You can have these different areas that will pull news information. And so it lists a long list of stories and articles that are coming on for that day. And it's just not the United States, anything going on across the world. And so I find that to be very informative to keep up on the latest events that are taking place. Not only the climate extreme events that are occurring, but just the way climate research is going on and how the different countries are dealing with climate change and trying to solve it. So I think it's a very good way to keep on top of things.
Thank you.
You're welcome.
Yeah, excellent question, Wharton. Thanks so much. I see that Jim here writes for you, Bob, in the chat. Do people tend to be more receptive, as far as your experience, to climate information after extreme weather events, or are they just overwhelmed by that event and then ignore the connections?
I believe that it is. People have short memories to a large degree, so the sooner you can tie in a climate change relationship with a specific extreme weather event, the better. That's what I do routinely on my television broadcasts. I wait until there's a significant event of some kind to present, the climate change aspect to that. So I don't know if I'm exactly answering your question, but I think the sooner you can do it in relation to the extreme event, definitely the better.
I know there was actually a political science study that was done a year or two ago that actually looked at how extreme weather events affected local elections as well immediately afterwards. So if people are interested on that, Jim, I'll make sure to include that link in the slide deck as well. And I just do want to put out a quick announcement. I know that I've gotten a couple of private questions. Not only will this recording be available, but also the slide deck will make sure to be posted on Community as well. So keep your eye open. We should have that up and running by tomorrow, and it should be in the previous webinars links. So make sure to check that out. And obviously we still have a good 8 minutes for questions here. So I'll turn it back over to you, Rick. I know we've probably got one or two more in the chat.
Yeah, I see that Abaya has put a note in the chat saying that the university that is strong on attribution science may be Penn State, where of course Michael Mann is. And I think too that David Titley, the professor of meteorology, is there at Penn. And there may be other universities doing attribution science, of course, but Penn State is one of them.
Yeah, when I look at my AMS bulletin here for the attribution, it does get all over the place. Not only in the United States, but this is a worldwide effort going on. 2015 European heat wave, for example. 2015 extreme drought in Western Canada. There's literally 28 different extreme events that have been researched and given some attribution to, but it is worldwide and among many climate scientists that this effort is going on, which is very important.
Yeah. I see another question from Claudia Egelhoff. Do weather presenters have other explanations for climate change, such as other possible causes?
Yes, they do. There are deniers within our profession, unfortunately. They're a minority, but they're there. But that is definitely a minority. I think you saw the statistics, most believe that climate change is happening, and at least half attributed to humans. It's just the fact that communicating that is a challenge. If you're a young broadcaster trying to get your career going, it's difficult to go that way. For someone like me I'm on the tail end of my career, I can push the limits a little bit more. It's much easier to do.
A couple of years ago, I saw Katharine Hayhoe give a talk up in Boulder. And she mentioned that there was a program to educate TV meteorologists or educate meteorologists who work in the media, I think through the National Academy of Sciences. but I've never heard anything more about that. Does that ring a bell, Bob?
You know, it doesn't. However, I've learned a lot just by looking at many of Katharine Hayhoe YouTube presentations. Learned a lot because I also present it from a faith-based perspective too, just like Katharine does.
Yeah.
Through my church, I go to many congregations. So the way that she presents it, what I'm really impressed with Katharine is how educated she is about the social aspects of climate change,
Right.
how you communicate it. So I think just looking at her and watching many of her presentations, you learn a lot.
Before we run out of time, a couple more questions have come up. Has Bob explored the connection between climate and the severe blue-green algae event in the Madison Lakes? There's a good one.
That is a good one. I have not, but that research is ongoing. I know that is, I don't research, I'm a communicator. I forecast the next 7 days.
Sure.
So I leave it up to the researchers, the ones with doctorates, to do this kind of work. But there is research going on in that. And, you know, there definitely is a cause and effect there. We have Madison has lakes around it. It's a beautiful city, beautiful setting, but our lakes are becoming more and more polluted. And we know it's to a certain extent because of the warming of the atmosphere and of those lakes, but I haven't seen any direct attribution yet.
I've been fishing in your lakes. In fact, I caught a nice walleye out of Lake Mendota once.
There's a great question. There's a great question here, I think, is a wonderful way to close it from Michael, who asks, are any suggestions do you have, Bob, for CCL volunteers as far as, you know, especially from a meteorology background yourself, how can we approach our own meteorologists to start talking on air more about climate change? You know, what recommendations or next steps might you have on that level?
Great question. I'll mention that personally, I'm trying to do that myself. I'm starting in Wisconsin, communicating with other TV meteorologists. I'm trying to get them tuned into CCL and hopefully get them to join. But what I would do is simply email. I would copy not only the meteorologist, but their news director, because he's the one that the meteorologist has to convince that I want to do this. But if enough people communicate it, they're very sensitive and watch very closely all emails that come in. That's the way I would go about it. Either that or through social media too. You can Facebook. They're very tuned into all social medias as well. But you can make a difference.
There is a website that a gentleman in Chicago has started called 50yearforecast.org, I believe it is, which lists all kinds of contacts for meteorologists all over the country.
Good point. I've seen that. Yeah,
Mark Mesley, yeah.
That people can check out.
Yeah.
So we have two quick questions here, and we got 2 minutes. One of which is, you know, from Jim. He asks, you know, are there other sources that you're aware of? This might be more of a Dr. Francis question, Bob, but, you know, she mentioned Munich Re and the reinsurance data that she had to show the increasing intensity of extreme weather events being reinsured. Are you aware of any other sources for that history of extreme weather event occurrences and intensity?
I am not. I'm not.
Do you know, Bob, is there a forum or conference attended by many in your field as weather forecasters? You know, and if so, is this topic presented or debated on at that conference?
It is. The American Meteorological Society, we have a broadcast conference, and it just happened in June. As a matter of fact, it was the week after our national conference. And one of the major presentations was on climate change and communication. So it's a subject that the American Meteorological Society really pushes our television broadcasters to communicate about, and we're getting that kind of communication in our conferences.
You know, the cooperation between climate scientists and the communicators like Bob is really important, and I hope it grows and becomes productive and help us reach our goal.
Here's to that. Bob, you're doing wonderful work. We're so grateful for you not only to do that in the field, but to make time tonight. And a big shout out and thank you to Dr. Francis as well for all of her ongoing research and engagement. Rick, thank you again for putting this together. Rick was the man behind the screen to get this all happening at the conference. And now we've had a chance to share this to the larger audience. And we hope that everyone tuning in tonight found value out of it. And we wish you a wonderful evening, everyone. Thank you.